Hello students, in this video we will learn about the comparison between the single layer perceptron and the multiple layer perceptron. So you all know that SLP, the layer is formed by taking the processing element and by combining with the other processing element. And but MLP, we see that the network of the layer of the neurons is formed by the interconnection of several layers. Okay, so and we have also seen that there are hidden 1, 0 to several hidden layers in multiple layer perceptron, but in single layer perceptron, there are no hidden layers. And here we see that this is applicable for the linearly separable data point, and this is applicable for non-linearly separable data points. So SLP, where we see that the input is linked with the output, okay, and we see that this is a feed forward where the input is taken and then we do perform the summation of the weight multiplied by the input, and then the input is forwarded to the output neuron where the computation takes place. So here this includes a back propagation. Okay, so where depending upon the error that is calculated, and if there is the accuracy is less, we go back and do perform the weight updation. So now understanding the difference, now we are moving on to the next topic, that is Naive classifier. A Naive classifier, it is a probability based classifier. So this works on the theory of probability or the fact. Okay, so how we'll be able to predict the future events. Okay, so based upon the probability of the event which had already taken place. A Naive classifier, these are all the features of Naive, and this is the supervised learning algorithm, and this is used for solving the classification problem. And this belongs to the family of probabilistic model, and this also helps us to predict the future events. So on the basis of the probability of an object. So this works on the basis of Bayes theorem. Okay, so now we will see what is the formula that is used for the working of the Bayes theorem. So before that, what are all the things that is needed? Say, for example, you have a historical data. That is, you have the features such as dark cloud, wind, humidity, and rain. Okay, so and this is the target class that you want to do the prediction. Okay, so and the task is whether there will be a rainfall on a particular day or not. So based upon the given input, there is a dark cloud and the wind is very speedy and the humidity is high. Okay, so whether on this particular input of a day, so whether it will rain or not. Okay, so we need to predict the class membership probability. Okay, so that is the probability that it will rain on a particular day given the input X. Okay, the input X is this is the input feature, and the probability that it will not rain and given the input feature. So we will compare both the probability, whatever is greatest, that will be the output for this given instance. So this Naive is a probability that uses the Bayes theorem, and this is the formula for the Bayes theorem. Okay, so that is P of C given X is equal to P of C multiplied by P of X given C divided by P of X. So here, this is the prior probability. Okay, so you should understand there are two different probability. One is the prior probability and the other one is the posterior probability. Okay, so prior probability is what we believe, okay, before we observe the data, okay, before observing the input instances. It is the belief how the output will be. So how likely that certain class would be. That is the prior probability. Okay, and posterior probability is how likely the certain class is true given the observed. So how likely the classes it would rain. Okay, so given the particular input instance, yes. And the next is P of X given C. Okay, so X given C, this is the likelihood. Okay, this is how likely the given observed data is. And the last one, P of X, it is the overall probability. Okay, so overall probability. So this is the equation for the Bayes theorem. So these are all the example. Okay, so and you have to understand P of C, it is the prior probability. Okay, so it is the general probability that a person has a disease before any test is taken. We have not taken, have gone for any medical examination. So before that, what is the belief we have? And P of X given C, it is the actual test probability. Okay, so like this is the likelihood probability. So it is the probability that the test is positive if the person is truly having a disease. Okay, and P of X is the overall probability. Okay, what is the total probability that anyone with or without the particular disease, okay, is tested positive. And the last one is posterior probability. Okay, so posterior probability is what is the belief that we have even before we have taken any particular test, before observing the data. Okay, this is posterior. Okay, so prior is before and posterior is, okay, so after observing. Okay, so prior is before observing the data. And these are all the steps. Okay, so how do we find the class label for the given instance? Okay, so the first step is you will have to understand the problem statement. You will have to observe what are all the events, okay, historical data set, what is the class probability. And based on that, you will have to calculate all the requirements that is needed for the Bayes theorem. That is the likelihood and the prior probability. And after calculating everything, have to apply it to the Bayes theorem. And then and assign X to the class that is having the maximum probability. Okay, so that we will see how these steps are taken with the help of an the example data set. So you are given with this problem statement, you'll have to understand the problem, and this comprises of the training example. And the question is like, you will have to find the probability, okay, the decision that you will have to go and play, given the input, the day is sunny, okay, and the temperature is hot, and the humidity is normal, okay, and the wind is false, and using the Bayes classifier. So first and the foremost thing, after observing the data set, you will have to calculate the class probability or prior probability. Okay, so prior probability before you observe any of the new instances. So what is the belief you have about the data set? So you are given with the features outlook, temperature, humidity, wind, and you will have to calculate find the probability that you will have to go out and play or not. So for that, initially the target class is play, okay, and then count probability. So play is, there are two outcomes, that is yes and no. How many yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times the count, okay, we see that out of 14 evidences, 9 days, okay, so they have gone out and played. The probability is given as 9 divided by 14. So similarly, no. So out of 14, 5 days they have not gone out and played, which is equal to 5 divided by 14. Okay, so the total count is 14 here. The probability is 1.0. So this is how we need to calculate the class or the prior probability from the given input. data set. The next important step is you will have to calculate the likelihood probability. Okay, so what would be the evidence of the class? So given a particular instance. So from this observation, okay, so the outlook. So for the first, we are going to calculate for the outlook and then the temperature and then the likelihood probability for the humidity and wind. So first, when we consider this outlook, so how many different values are there? There are sunny, overcast, and rainy. Three different values are there. Okay, and then how many yes and no? So on the day when it was sunny, if you observe sunny and it is the outcome is no, sunny, the outcome is no. Okay, but at here you have a sunny, the outcome is no. And here you have a sunny, but the outcome is yes. Sunny, the outcome is yes. Okay, so on the day, so when it was sunny, so 2 days, the outcome is yes. Okay, and 3 days, the outcome is no. So the probability of S is out of 9 days because the probability of yes in the previous step we have calculated. Okay, it is 9. Okay, so out of 9, so when the outlook is sunny, okay, the probability is 2 divided by 9. And the probability for no is the remaining days, it is 3 by 5. Okay, now coming on to the next value for the feature outlook. Okay, so it is overcast. So when the day it was overcast, we see that, so how many observations we have? Okay, so we have, so the overcast is, we have 1, 2, 3, and 4. Okay, so all 4 days, if you observe 1, 2, 3, and 4, okay, it is, we see that the particular, they have gone out and played. Okay, so the probability of yes has become 4 by 9 and the probability of no has become 0 by 5. So now coming on to the next value of the outlook, it is rainy. So it was when it was rainy, okay, you can see that rainy and 2 days it is yes, okay, and 3 days you can see it is yes. Okay, and the remaining days it is no. Okay, so and it is 3 here. Okay, so it is 3 days. It is yes. Okay, and 2 days it is no. So the probability for yes, okay, when the outlook is rainy is 3 by 9. Okay, and the probability of no is 2 by 5. So now coming on to the next okay feature, that is like for the temperature. Temperature takes hot, mild, okay, and cold. Okay, so three different values. So when it was hot, okay, so we see that it is 2 days, it is yes, okay, and 2 days it is no. So therefore, the probability of yes is 2 by 9, probability of no is 2 by 5. So similarly for mild, okay, so we see that 4 by 9 and then 2 by 5. And when the day it was cool, it is 3 by 9 and 1 by 5. So similarly, when the humidity is high, humidity feature, if you observe, it is high and normal. Okay, so when it is high, it is 3 by 9. Okay, and it is because you can even observe. Okay, so high along with yes, what is the value? Okay, so when it is high, okay, so high is no, 1, 2, okay, and high along with yes, okay, you can see that 1, 2, and 3. Okay, so you can see that when the humidity is high, we see that 3 days and it is yes, okay, and 4 days, okay, it is no. So the probability of yes is becoming like 3 by 9, okay, so and the probability of no, okay, and it has to become 4 by 5. So similarly, when it is normal, it is 6 by 9, okay, and the probability of no is equal to 2 by 5. So similarly, we have to calculate for the day when it was windy. Okay, so it takes two value, true and false. Okay, so true along with yes, it is 3 by 9. Okay, true along with no, it is 3 by 5. So this is how we need to complete the calculation of likelihood probability. So now after doing the calculation of the likelihood probability, so now given this instance, now we have to calculate the outlook. These are all the input feature. The outlook is sunny, temperature is hot, and humidity is normal, wind is equal to false. So now moving on to the testing phase. Okay, so here these are all the calculated probability and the class probability estimate, what we have already calculated. So now we have to outcome according to the Bayes theorem, the probability of playing tennis. Okay, so there are three different values that is given, that is sunny, okay, hot, normal, and wind. Okay, so when the day is sunny and when you consider the outcome as yes, okay, what is the answer we are getting? It is sunny and yes is 2 by 9. Okay, and the next is hot and yes. Okay, so when it was the temperature is hot, okay, and the probability of yes is 2 by 9. So you will have to multiply all the class probability, and the next is probability of wind is equal to yes. Okay, so wind is equal to yes is 3 by 9. Okay, so here there is a mistake. Okay, and the probability of yes, total probability is 9 by 14. Okay, so 9 by 14, you will have to multiply all these values and you will get 0.0141. So similarly, you will have to take the probability to not to play tennis is given by all knows. Okay, so that is 3 by 5, 2 by 5, 1 by 5, 2 by 5, and 5 by 14. So which is equal to multiplying all these values, you get the answer as 0.0068. So now we need to convert these into a probability by normalizing all those values. The probability of yes given today is equal to, so what is the calculated probability of yes, which is equal to 0.0141 and divided by 0.0141 plus 0.0068. So similarly, probability of no is, you will have to take 0.0068 and divided by adding the probability of both yes and no. So denominator remains the same for both. So the probability of yes is given as 0.67, no as 0.33. So predicting that the particular child will go out and play, so we have to compare both the value. So since the probability of S is greater than no, and the outcome is, we will have to conclude that the child can go out and play. So these are all the advantage, okay, and the Naive is one of the fast and easy algorithm, and this can be used for both binary and multi-class classification, okay, and this is most popular choice for the text classification. But the disadvantage, this makes an assumption that the features of the input data set are totally unrelated. Okay, so it cannot find a relationship between the feature, whether there is any correlation or no correlation. And some of the special cases that need to be considered. So the first special case is like when the attributes hold the numerical values. Okay, so when all the input feature what we have, okay, till now what we have seen in this example is the a categorical type of value. So if we have a continuous value, then we will have to calculate the likelihood is based upon the Gaussian distribution. So the formula for Gaussian distribution, you just understand, okay, where mu is the mean and sigma is the standard deviation, and pi, the value is 3.14, and E, the standard value is 2.7. That's it. You have to understand. And the next is zero probability. Okay, so zero probability is like, for example, you are given with the data set. For example, when there is no rain, okay, there is no observation in the data set where dark cloud is equal to S. So you observe that the dark cloud is equal to S. We have two input, but considering the output, okay, so we see that there are no evidences found in the data set. So when no such evidences are found, when you try to calculate the probability of rain is equal to no, considering dark cloud is equal to yes. So at that time, the probability will be calculated as 0. Okay, so multiplying 0 with any other value, that gives the answer as compare simply 0. So to avoid that, you can add a smoothing value, maybe +1, so none of the event is assumed to be considered as a 0 probability. So with that, like you would have seen, you would have understood about the Naive classifier. We'll see in some other topic through this video lecture. Thank you all.